So we're going to look at converting some fractions to recurring decimals. So we're going to start with the simplest way, which is take your fraction, stick it in a calculator, press equals. It'll give you the fraction back, but the SD button will convert to a format depending on your settings. Here it's got the 3636 repeating. Depending on your calculator setup, it might show it as a recurring decimal anyway with the dots above it. So that's always an option in the real world. But it might be quicker occasionally to do it without even bothering to get the calculator out the bag. So let's show you how it all works first of all, and then show you some shortcuts. So the basic theory is that this line in a fraction means divide in algebra, because it is in fact the same line. So this asks you how many times does 11 fit into 4? Well, it doesn't, but we have this other method. We can use proper methods to work out what's going in. So, I don't know why I started with a 4. How many 11s fit in 4? None, but all 4 of those are left over. So we now have a 40 in the decimal, in the first decimal column, the tenths column. How many 11s fit in 40? Well, 3. With what left over? 7. Well, how many 11s fit in 70? 6. With what left over? 4. How many fit in 40? 3. With 7 left over. How many fit in 7? 6. With 4 left over. And you can see we're going to get this repeating forever because the remainders will be the same. So this is 0.36 with both digits repeating. So it's the same for any fraction. We can do the division and rattle through. Some are longer than others, and if you don't know much about the number theory behind it, it might not be obvious which ones are going to go forever and which ones aren't, and how long the repeating cycle might be. So if we do 7s into 3, because we are dividing, it will either stop or it will repeat forever. There'll be a repetition somewhere. So 7s into 3 don't go, with all 3 left over. 7s into 30 goes 4 times with 2 left over. 7s into 20 go twice with 6 left over. Well, this looks like it's going for a while now. 7 into 60 goes 8 times with 4 left over. 7s into 40 go 5 times with 5 left over. 7s into 50 go 7 times with 1 left over. 7s into 10 go once with 3 left over, and we're back to this 30 again, which means I'll have the same 4 and the same 2 left over. So all 6 of these digits repeat. It wasn't obvious at this point here, when you were 4 digits in, whether it was going to finish or go forever, or be a long repetition. So some things here, even though 7 is smaller than 11, it's got a longer repeating segment. So it's not always obvious how long the repeating segment is. You have to bear with it, and also check you've not made a mistake, because sometimes you can end up getting the wrong remainder. So all of that repeats. So that is the brute force, always works but not always quick way of doing it. The calculator always works but requires no brain power, and if it's a non-calculated question you can't do it, probably not got it in your bag, you can't do it. There are some rules and shortcuts. So you'll notice that we've got these remainders that are quite important. Because 9 is very, very close to 10, and we work in a base 10 system, it always has a simple remainder. So fractions out of 9 actually have a really simple property. 2/9 is going to be 0.2 recurring, just like that. Because the distance it is below 20 is 2, it's the deficiency is kept in sync. So 7/9 is 0.7 recurring. And it's that simple with 9ths. With 99ths it's also really very simple. It's going to be 0.23, both recurring. And with 999ths, sorry, looking off the bottom here. With 999ths, it's all 3 digits recurring. So if it's out of 999, it's very easy to do. And that's a useful shortcut to save you doing all this division from before. So a simple thing to do with fraction knowledge is, just like we like tenths and hundredths for simple decimals, for terminating decimals, we like ninths, 99ths, 199ths and so on for recurring decimals. So that means there is in fact another way to do these questions, a third way. And this third way, if I can get it on the screen up here somewhere, is to do with remembering our facts for the 9s and 99ths. So I can turn this 33 into 99. How did I do that? Well, I multiplied by 3, which means using equivalent fractions, that's going to be 30. So that means this decimal is going to be 0.303030, which is 0.30 with both dots. So even though there's a 0 there, it's still part of the repetition. Similarly, this 111 can become 999. That was multiplying by 9, so that is multiplying by 9 because of equivalent fractions, and we get 18. Now this one has a little thing you can make a slip up with if you're not following. That has 3 9s, so there should be 3 repeating digits, but there's only 2 here. You have to remember that as well as there being units and tens, there's also 0 hundredths. So this is 0.018, 018, 018, etc., which can be written as 0.018 with the 2 dots. So, 4 methods really, or 3. Stick it through a calculator if you've got one. They exist, don't worry about it. If you haven't got one to hand, or you're not allowed it for the exam, or whatever situation it is, you can use your brute force division, because that's all this is doing, by the way. This is what's going on in the calculator chip. It's just doing division and counting remainders, and once it spots a repetition, it'll stop, depending on the settings. The other way is to actually use some mathematical knowledge, and that will become important in some actual more problem-solving questions, is to knowing that 9s and 99ths are useful, and if you haven't got any of those, you can convert to them by using equivalent fractions. So I hope that helps, and enjoy the work I set on this.